Hi everyone, my name's Ethan and I'm one of the industrial engineers for this team, and I'm also the team lead for this project.
Hi, I am Madi. I'm an industrial engineer and I am the procurement lead for the project.
Hi, my name is Walker. I'm the electrical engineer and I'm the electrical lead for the team.
Hi, I'm Yusuf. I'm one of the electrical engineers for the team, and I'm also the requirements engineer.
Hi everyone, I'm Arthur. I'm a mechanical engineer and I'm a mechanical lead for the project.
Hello, I'm Trinity Brandt. I'm a mechanical engineer and I'm the 3D modeler for the project.
And we are Project 2419, the battery charging system sponsored by Resolution Copper. Now, who is Resolution Copper? Resolution Copper is an underground mine 60 miles east of Phoenix in a little town called Superior, Arizona. As you can see from the video right here, the mine extends over 7,000 feet below the Earth's surface. It also contains one of the most significant untapped copper deposits today, totaling at about 1.787 billion metric tons at an average grade of 1.5%. This has the potential to supply the US with 25% of its copper demand today. And we just kind of wanted to include this picture right here to show you guys that a conveyance cage is just a fancy term for a mine shaft elevator, and that it extends over a mile under the Earth's surface, transporting equipment and people up and down all throughout the day. And on board the conveyance cage, you can see to my right hand side here that there's a communication system that the miners use to communicate to the workers at the top. This communication system is powered by a 12-volt battery, which you can see all the way to the left over there, that needs to be changed at the beginning of every shift. And now you can see to my right here that this is Resolution Copper's battery charging cabinet, their current solution in changing out a battery every single shift with a fully charged one from this cabinet. Our job as 2419 is to completely eliminate the need for this cabinet all in all by creating an automated battery charging system that will withstand their corrosive mining environment. Now I hand it off to Yusuf.
Thanks, Ethan. Now I'm going to go over the critical requirements of this project. Getting into the operating conditions at the mine, the environment is highly corrosive, high humidity that can reach up to 100%, and high temperature that can reach up to 130 Fahrenheit. And our system will withstand this harsh environment. This is the mine where our system will be installed, and as you can see, guys, the environment is extremely harsh and our system will withstand this extremely harsh conditions. Getting into the critical requirements of our system, for the output rate, we're gonna need 12 to 14 volts at 10 amps. For the corrosion resistance, we got a polycarbonated plastic housing that is IP66 rated, meaning that it can withstand damp conditions and corrosive environment. Furthermore, we're gonna seal the wires to protect the inner circuits.
Hi, I'm Walker, and I'll be taking you through some of the verified results that we've recorded over the life of this project. So MVP1 was an initial prototype that we used to better understand the hardware requirements for wireless power transfer. We found that a single turn of wire was not sufficient enough to provide the magnetic field strength to achieve our requirements. Additionally, we found that identical coils allowed us to better couple the inductive energy and improve efficiency. MVP2 reinforced this observation and prompted us to build an accurate simulated model to better understand how the components affect the system. We define our MVP3 to be a pair of coils whose turns ratio is 1:1, making them identical. While increasing the number of turns per coil to 10 turns each, this increases the amplitude of the magnetic field. This is our LT-SPICE simulation model we're using for the circuit. Comparing the results of our MVP3 test with the model, we're tracking within 20%, and this will give us a good estimate of how our system will perform under higher power conditions. Based on the input of 68 volts applied to our coil, we'll be able to receive an output of about 28 volts and 5.5 amps, giving us a total of 154 watts of power available. After a DC converter reduces this down to 12 volts, we should be able to see about 12.8 amps of current. So to test our coils, we supply the driver circuit with a DC input and measure the output on the receiver coil. The resonance between the coils will produce a sweet spot where maximum power transfer can be transmitted wirelessly. The goal of this test is to find that sweet spot and maximize the transmitted power to meet our requirements. Here are our verified results. Our goal is to hit our 120 watt charging requirement, but with our current hardware, we're only able to get about half of that at 52.2 watts. We're currently developing a more robust driver circuit capable of handling the high power input values. However, our project meets the corrosion resistivity requirement, as the housing units we implemented are ingress protection rated of up to IP66, and our system will be fully autonomous due to the implementation of an ultrasonic sensor that will detect the position of the coils and activate the charging state. So that wraps up this section, and now I'm going to pass it off to Trinity to go over the automation and mounting processes.
Thanks, Walker. And now I'll be getting into the disciplines of engineering for our project. This slide shows the main responsibilities for each discipline. Our mechanical engineers utilized 3D modeling to create a visual representation of our project and did technical research on requirements and standards to follow. Our electrical engineers designed all the electrical circuitry and the board layouts, as well as programming for the controls of our system. Our industrial engineers focused more on management, taking charge of all the part procurement and communications between our team and our sponsors.
Hello again. Now I'm going to introduce you to some of our critical risks for the project. So let's start with sensor implementation. This is a high risk since without proper function, the system will not turn on and off at the times it needed to. To mitigate this, we have ran several tests and troubleshooting to make sure it works and we can catch any problems with the equipment we have. Going down to elemental corrosion, given the environment we're facing, the system might corrode and be compromised. To avoid that, we have a polycarbonate housing to protect our components. Finally, our supply chain has always been a risk to consider, as late parts are never good to finish a project. So we have been keeping in contact with our companies, and we can also contact Resolution Copper for the trustworthy suppliers in case of any problems.
Hey, it's me again, and I will be walking you over through the financial analysis and the design day poster. Let's go. I will be breaking down our budget analysis for you. I have categorized our costs into two major sections, one being the electrical components, which consists of the coils and the sensor assembly for a cost of $897.29. The second section being the manufacturing category. This section includes the housing assembly for a cost of $613.09, leaving us to only a cost of $1,510.38. In the poster, I have included a description of our project, our solution to the problem, how it works, the system block diagram, visual images of our design and results, finalizing it with our conclusion. Now, I will be handing it off to Ethan for the next section.
Thank you, Mari, and now I'll be finishing off with the impact of this project. And so the issue was here that Resolution Copper wanted to automate this process of changing out the battery every shift. So all while making it more autonomous, we improve the efficiency of the mine operations and safety of the maintenance workers by reducing the labor hours by 2. Overall, we created an autonomous inductive battery charging system that withstands the harsh corrosive environment it's placed in and eliminates this daily chore, satisfying all the criteria and requirements of our project. I hope you enjoyed and thank you for watching.